Hello, my name is Britton Dedmon, and today I will be going over the trig functions and right triangle trig ratios. So first to review, we're going to go over SOHCAHTOA. SOHCAHTOA is a tool you'll use very often when performing functions and ratios. So first, SO is sine equals opposite over hypotenuse. CA for SOHCAHTOA is cosine equals adjacent over hypotenuse, and TOA is tangent equals opposite over adjacent. A few other terms we will need to know is sine. Sine represents the y value of an ordered pair. For example, x comma y would be the sine value. Cosine also relates to that ordered pair, and it represents the x value of that ordered pair. Theta is this value right here, and it is used when solving for an angle. So if we're going to solve for the sine of that angle, we're going to say sine of theta if we do not know that value of that angle, or if we're just talking about in relation to that angle. A trig function is a function that relates to an angle of a ratio. So we use that ratio to solve for that function, and a trig ratio is what we use to solve for that function. Here's an example of theta in relation to the right triangle. And remember, so the x comma y value is your cosine over your sine, and this right here is your hypotenuse and also the radius of the circle, and it will always be 1. So your x value in this case in relation to theta is adjacent to theta, and your y value is opposite to theta, and again this is just the hypotenuse and your radius. So now we will find the following trig ratios. So first we are going to look right here. So x over 1. Anything over 1 is that value. So in this case, x over 1 is adjacent over 1 or just x. And remember when we're talking about the ordered pair, x is cosine. So we can just write cosine here. We are also solving for this triangle right here. So cosine of angle ABC, so right here, ABC, would be cosine also, just because you solved for it already over here, we can just put it over here. Again, something over 1 is that. So y over 1 would be y or sine. And again, we can just write it right here. Now we will look right over here. So x over y would be adjacent over opposite. And if you remember going back to SOHCAHTOA, opposite over adjacent is tangent, TOA. So this would be the inverse of your tangent due to the fact that it's 1 over tangent and not tangent. So this would not count for this value right here. Now moving on to y over x. That would be your opposite over adjacent. So that would be your tangent. Oops. So that would be your tangent right here. Now going to your a over b, so we're going to be looking right here. That would be your adjacent over your opposite in relation to theta. So adjacent over opposite is again 1 over tangent or the inverse. Now we will be looking at b over a, which is your opposite over adjacent. So opposite over adjacent would be your tangent. So again, we already have that value. Now c over a would be your hypotenuse over your adjacent. So hypotenuse over adjacent is the inverse of cosine. So again, that would not count for this. That's just the inverse. Now a over c would be your adjacent over your hypotenuse. So that would be cosine. And we already have it, but that's another value. So b over c would be your opposite over your hypotenuse. So opposite over hypotenuse, going back to SOHCAHTOA, is your sine. So there you go. So it's pretty simple. You follow your SOHCAHTOA and you will be able to find these trig ratios. Thank you very much for listening.